Okay, 8.2, number 3. Now, this is a different scenario. The pressure is getting to you. It has made you sad. You just say, you know what? I can't take it anymore. I'm going to begin my new life under the sea. So, here is the sea, and you're going to start your new life under it. Here is your house. There's your house, and it is under the sea. I don't know whether there's smoke coming out of the chimney under the sea, but I don't know much about living under the sea. Now, coincidentally, your house is the same distance under the sea that it was up here. So on your biometrics page, you have a distance from your home to there. In my case, it is 12 kilometers that I'm away from my home. Just, in this case, 12 kilometers of depth. So let's go ahead and start working with this problem. Now, the formula for pressure is the atmospheric pressure plus the pressure due to your fluid, which is a combination of the density, gravity, and the book says height. Do you ever think about, oh, you're underwater. How high underwater are you? That's what the book says, but I'm just going to put down depth, okay? And let's put in our numbers. Now, pressure, the atmospheric pressure is 101,300 pascals. Again, I put into pascals. I've taken out of kilopascals and put it into pascals because in general, these numbers are going to give you your number in Pascal, not kilopascals. I didn't need to do that, and you'll see why I didn't need to do it, but I'm going to just do it for the sake of continuity. Now, the pressure, the density of water, salt water, seawater is more dense than fresh water, so you get 1,000, what did I get down here? 1,025 kilograms per meter cubed, plus your ocean is still on Earth, Earthlings, so that's going to be 9.8, or not plus, sorry, apologies, times 9.8 times my depth. Now, remember how I said you didn't need to change this in the pascals? You could have left it at kilopascals? That is true. But let me explain what would happen if you did. You see, my depth was 12 kilometers. If I had left the kilopascals in there, if I kept this in terms of kilometers, no, actually, hold it. That's not true. I have to change it to meters. Oh yeah, and actually, sorry, no, I could have left it. I could have left kilopascals here and kilometers here, and I would have multiplied this out, and I would have gotten my answer in kilopascals. The thing about math is you can put a kilo prefix in, and you run it through just like numbers, and we'll go right through, it'll work. But you got to trust me on that. Let's just put it in meters, okay? So 12,000 kilometers is 12 kilometers is 12,000 meters. But again, if I could have left that in kilo, and this would have been kilo, and we would have ended up with kilopascals on both sides, and it would have worked. Some people might not feel confident doing that, so we're not going to do that. Now, atmospheric pressure is still 1,100. Or 101,300 pascals plus. Now, if I multiply this together, you'll notice you get a very, 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 very large number. And in fact, the number I've gotten is 120 120,540,000 pascals, which is a lot of pressure. If you were going undersea to escape the pressure, you've gone to the wrong place, but it's a different kind of pressure. Some people cope with it better. All right, so I add this all together, and what I get is the pressure is equal to 120,641,300 pascals. Now, if I kept this as kilopascals and kept that as kilometers, and everything would have gone through here, well, let's worry about that in a second. So we're going to round it. 2 sig figs is our limiting factor. That was also only 2 sig figs, 2 sig figs. It got to round us to 2 sig figs. So I end up with pressure is equal to 120 million pascals. That's our answer. Now, if you kept this in kilopascals, you would have gotten 120,000 kilopascals. Either answer would be correct. In fact, you could even say 120 megapascals if you want. Either way is correct. If you kept the kilometer in and the kilopascal in, you would have ended up with that. It would still be correct. You're just different, same thing, different units. Now, I want to point out a couple things. One, your number's going to be smaller than mine. Because I live in Monrovia. That's 12 kilometers away, 12,000. You probably don't live that far away, so you're not going to have that kind of depth, which means this multiplier is going to be a lot smaller than you. Same ocean, same earth, the depth will be less, that will be less. Remember, this is the big factor. The last time we did it, the air pressure is the big factor, but this is so deep underwater that the depth of the water is the biggest factor. In fact, look at this. When I added in air pressure, it went from 500,000 to 600,000, right? But when we rounded to 2 sig figs, the air pressure doesn't even appear in your rounded number. If I had left the air pressure out, I still wouldn't get anywhere near what it would take to round this up to 121 or down to 119. It has pretty much the air pressure when you're down that deep. It doesn't even really enter into it. Now, that's one thing I wanted to point out. One, your pressure is going to be less because you're probably not farther enough away. Two, when you're down that deep, who cares about the weight of the air on top? And one other thing I wanted to point out is if you're down that far, this is 120 million newtons on every square meter. I mean, a square meter, well, it's about that big. Imagine a square. Each square meter has 10,000 square centimeters. If I divide that by 10,000, you've still got 12,000 newtons on every single square centimeter. Think about a square centimeter. We're talking about the size of your fingernail. 12,000 newtons on that. That is more than a ton of pressure on an area that small. So the pressure, you can imagine, deep down there is extreme. And now, by the way, this is about as deep as the ocean gets. But you can understand why people don't go to the very deepest part of the ocean very much. That's just tremendous pressure. Do we have materials that can take the kind of pressure? Yes. Is it easy to build them? No. Is it expensive? Yes. Do we take this lightly? No. So, you probably don't want to choose this place to live. Anyway, there you are. Bye-bye. I'll see you under the sea.